first ever YouTube video that I'm recording on this. So what we'll be covering today is the VPC sizing, which includes classes, CIDR, subnets, IPs, and its calculations. So the way we will be doing this is we'll use a scenario and then we'll just build up on it or work on it. Now we have a marketing company. As you can see, this is my drawing. This is the marketing company. Okay, this marketing company has 500 people working for it and it's rapidly expanding, right? Which is basically a medium-sized business. Now this business has 4 different departments. We have, as listed here, we have the IT department, we have the HR department, we have the research department, and the production department. I don't know if these are used in marketing or not. Most likely they are, but there might be more relevant ones. But here in this scenario, we're going to use 4 different departments. The ones that came up in my mind were these 4. Now these departments need to communicate. The business itself needs to communicate, which has these departments using the internet. As you can see here, so the arrows are flowing from the building to the internet and different places. Moving forward, now there's different classes, and before we move to the classes, the whole entire internet it started off with this 0.0.0.0.0.0 4 zeros /0, which is the entire internet. Now the amount of IPs, which is internet protocol, the amount of IPs we have with this is 4,294,967,296, right? Which is 2 to the power of 32. I'll dissect that further. So this is the amount of internet space we have. This is how many people can use each. So if we give each one of the people's an IP, we get to that number. However, we nowadays have a lot more. We basically have double the amount of the world's population, and we're running out of these IP addresses. So what they have done is they have made some classes. So this is the initial part, and then after when this was done, which was done in the 90s, I don't know, 19 something, we have they made the classes. Now there's different types of classes. Each class has a size associated with it. So class A, which is the biggest one, they are from 0 to 127, and then this is the host. So there's host. Okay, so these are used to help people identify, or companies be identified, for example on the internet. I want to keep it very simple, so I'm going to use very simple sort of examples or definitions, just to give you the idea of how it works. So 0 to 127, which is only for this, we have for class A. These are large organizations. As you can see, I've put Shell here, which is an international company, is worldwide. Then we have NHS, which is based in the UK, National Health System, healthcare, which has millions of people working for it. We have McDonald's, which is also a worldwide company, and they are massive, so they are in class A. Class B is usually for medium to large size businesses, so anything between 128 to 191. So the way I've done the X's here is, this is how much host space there is, so the last 3 zeros for A. For B, the 2 last zeros is for B, so you can use these to classify the subnets depending on what class it is. You can divide them into further parts of the network. As I said here, it's the medium to large. So our business has 500 people working for it, which is a medium-sized business, and therefore we most likely further on after this slide we will be using class B actually. Yeah, so we have for medium to large, we have Harvey, we have Arch Resources. Class C is 192.223, so the last 0 is left, the rest is all used for networking. Alright, which is between 192 and 223. This is used to further break down the network into subnets. So it is small businesses, you could say people with, well, a business with about 50, 100, 200 people working for them, local area network. Then we have Class D and Class D is for is there's no hosts on this, okay, but instead it's used for multicasting. Multicasting is basically sending data across a computer network to several users at the same time, usually for gaming. That's as far as I can relate to right now. There's other places that is used, but gaming is a very big example. Class E is 240 to 255, which is reserved for research purposes. Now, when you have the /32, so here we have 0. When we have the /32, it means a whole IP address. So it represents a single IP address. For example, 10.8.127.52. This is the exact device that you want to connect to. So if you have this, you will connect to the exact device that you want to communicate with. Moving on, here I've done a pie chart. It's just to show you how much space is being used between each of these classes. So Class A uses the majority, as you can see. Class A is the sky blue color. Then we have B, which uses this orange color. C, gray. D is the yellow, and E is the dark blue. Remember, 4,294,967,296 IP addresses. This is all of it, and it's divided into different classes. How you work out this is 2 to the power of 32. I'll expand this on the next few slides. Now what we want to do here is we want to work out how you calculate the IP, the network subnets. First of all, you need to have an idea of decimal to binary. I have given a video link here at the bottom on the right corner, which is done by Sunny, the person that's doing this video, to explain how this works. I would, those people who don't know, it'd be best to watch this first in order to get to know this and the rest of it. The first few, just to start off, the first few are for, so the first few octets, so 8, 8, 8, 8 are used for the network. Depending on what the number is here, this is called the prefix. This tells you how much is for the network. So because it's a 500, the business size is about 500 people, we have, it's Class B, we have the first two used, right? So 10.8 is for the network. We cannot change this. Alright? So as you can see, we have got a table here which shows the network, the blue color. To get to 10, if you go into this box here, and from binary we're going to find out the decimal. We go to the not higher than 10, but just about 10, or the one below 10. So if you can see, 1 is a lot less, 2 is a lot less, 4, 8, 16. 16 goes over. So we can't take this. We go to the last one, which is 8. So we use the 1 here. So we use this, 8. We need to get to 10, so we do it again. So 1 plus 8 is 9. Now we can do 2 plus 8, which is 10. So we add the 1 here. So 1, 1, the rest are zeros because we don't need them. We only need 1 here, 1 here. This makes it 10. Same for 8. 1 is less than 8, 2 is less than 8, 4 is less than 8, 8 is equal to 8. So we don't need to go further. We can just use this 8, 1. So we have used a 1 here. The rest is all zeros. This is just an example. So this is from the last one. So if we change this to 0, it's 8 now. Yeah. And then for the host part, which is basically changing into subnet, the 0 denotes the full range of this. We have 255, so it's all on. In binary, it's 0 or 1. 0 is off and 1 is on. So all these numbers added up together, as they're all on ones. 1, 1, 1, 1, 1 for each one of these. It adds up to 255. So 0 to 255 is the options we have. right? But we haven't worked out here, so I'm just showing you how it's separated. So network host is 16. So in the next one sec slide, you can see how it works. So we have the 10.8 or 0.0/16. Someone wants to communicate using the internet to this marketing company and to one of these departments. It goes through the internet with this. So class B assigns us an IP address with the first few octets for network. So the first 16, so 8, 8 is 16. So the first half of is used to get to this building. Now to get to the right department that this person wants to communicate to, we need the rest of the IP address. So we have to divide them into equal 4, or depending on how much we need to use. But we haven't got this done yet. It will get us to the building, the marketing business, but it won't get us to the right department. It will just get us to the building. We need to get to the right department. So let's say the person wants to communicate to someone in the IT department. We need to assign the last two zeros with numbers that will get to this IT department. So we're going to further dissect on this IP address 10.8.0.0/16. 32 is the whole IP address. So for example, if it was 10.12.192.56, that would have been a full IP address, meaning you will go to the exact device that you want to communicate with. But here we haven't got this number. We only have the first half, and the rest half we need to find out and give it to each of our departments. So take away the 16, which is used for the network, so these first two, 10.8. To find the building organization, which is, as I said, the first two. You're left with the last two. So I'm using the X's to show how it works out and which ones we are referring to. Last two is 0, 0, these two. Now we need to break these down into 4 parts for the departments. Alright? The last two, 0, 0, mean we can use all of the 255, 255 and assign them for subnet. So if we divide the first 0, which is this one here, which is a total of, if you go into binary, a total of 255 divided by 4, which because 4 departments, it is 64 rounded, right? So 255 divided by 4 is 64. This is basically saying, so I'm going to give you another example within this example. If you have 100% and you want to divide it into 4 equal parts, you make it 100 divided by 4, which equals 25%, 25%, 25%, 25%, equaling to a total of 100%. That's what we've done here. So the total you can get is 256 divided by 4, which is 64 rounded, right? 64 for the first IT department, 64 we can give to the HR department, 64 IP addresses we can give to the research department, and 64 to the production department, which is a total of 256 as far as I know. Yeah, 256. Now the first, as I said, the blue ones are all the networks, so we won't be changing that because that's given to us by class B. But the last is what is given to us. You need to remember another thing is always minus the 64, whatever the total comes up to, by 2, because the first and the last IP address are used so for broadcasting, which is the last one, and the first one is used to denote this IP subnet. So we can't use 0 here, we use 1 to 63. 64 is used to broadcast. Okay, again this range here is 64, because we finished here at 63. This goes to HR 64, as we said, this is the second department. 64.1 to 127.254, 128 to 191, 192 to 255. Okay, let me show you how this is. So as you can see, same drawing as the last slide with this drawing. Someone wants to connect to our departments. Let's say they want to communicate, they want to ask a question. Internet 10.8 takes us to this building here. It's class B, but within that network, we need to communicate to the right department. So the first one was for the IT 10.8.0.1 to 10.8.63.254. This all goes to this IT department. Okay, so if someone has something around this, it will go into this. Someone has something like this, it goes into the HR, research, and production. Reserved IPs for AWS and Azure. There are, so as I said earlier, there's -2, right? -2, one is for the network address, but sorry, the first one is network address, but the VPC router. Okay, so I'll just go in order. First of all, we have number one, the network address, which is 10.16, which is for the class, or in this scenario that we're using is 10.8. Okay, that can never be used, that's given to us by the class. B, VPC router +1, so 10.16 plus 1 is to network address. So whatever the subnet is, as I said the last slide, as we saw, 10, let me go back. So 10.8.0.1, the first one is used for the network address, which is used by the VPC router. Router is something that directs the traffic to its place. It basically manages the IP addresses. Network +2 address, which is second address of the network address, used for DNS. +3 to that, which is used for future possible use network. So in the future, if you have something going on or you want to make some changes, you have something reserved on the side, which is +3, the third one. And the last one, broadcast address, last address, cannot be used because this is how people communicate with you. In AWS VPC, the smallest prefix you can have is 28 and the largest is 16 CIDR. And that's the same thing with Azure, that you can, these first 5 are reserved. Okay, binary bits that are ones are network and zeros are hosts. Alright, we're going to do another one just to give you the gist of how we have worked on the first one. Now we're going to work on the second one, so it gives you an idea of how we are dividing this network into further smaller networks called subnetting. So 10.8 is used, in this one is the prefix is 24. So remember, we cannot use the first 24 of the octets or the binaries because that is used for network. So this is a small business now. This is used for small businesses. So 10.8.127, these three, class C, is used for the network to get to your building. And this one we can divide into 6, 8, 10, wherever, to get to our departments, or yeah, I want to keep it simple, I don't want to go further, so I'll just keep it to departments. Here we're going to use an example. We're going to go and divide it into 8 parts, so the subnet, into 8 different departments. So x.x.x is used, 10.8.127, which is the network. 255, we can play with this, okay, so we can make into 4 parts. As we are doing here, we're going to do 8 parts, so we want to change it a bit. 255 divided by 8 equals 32. So each department, if it's 8 departments, is going to get 32 IP addresses, 32 per subnet. Okay, there is a calculator that can help you, and I would strongly suggest after this video you have a practice on this. Now, because I had to paste a table here, I didn't want to do that, it was taking a lot of space. What I've done is I'm going to copy the link and just put it here. Let me resize. Can I resize it? No. 1 second. Okay, it's a subnet calculator version IP4. First for you put the network address. So what we had on this one, we had 10.812724. So that's what we're going to do is 10.8.127.0/24. Okay, so the network is done. Let's leave the subnet mask. Number of hosts. Okay, number of subnets. How many subnets do you want? We want 8. Right, we leave those. It will calculate this itself. You want 8 subnets. 8. Now it's saying number of hosts in a subnet is 32. Same thing that we calculated here. 255 divided by 8 is 32. Okay. And it gives you the host address range. So it starts from 1 to .1 to 30, the first set. Then the broadcast ID, which is the last one, and this is 31. CIDR notation. And here's the table. So into 8 different networks. So we have 1, 2, 3, 4, all the way down to 8. Subnet address, it starts over 127.1 to 127.30. And this is the broadcast ID, so we can't use this. Same thing this. So every time we go from 1 to 2 to 3 to 4, each one of the subnets will have 32 hosts. Okay, 32, 32, 32, 32 will add up to 255. So same thing as I said earlier. If you have 100%, you divide it into 4 parts. So equal parts. You have 25, 25, 25. Yeah. I hope this helps. As I said, this is my first video. I've never done it before. It might not be the best, but the ultimate goal of this video was to help you understand how this works. Right? So there's nothing else that I want to do except help you to understand how this whole thing works. Now, let me see if there's one last slide. Now, before you actually assign subnets and break the network into smaller parts, which are subnets, you have to do the CIDR. So CIDR, I should have said this earlier, is classless inter-domain routing. You need to know the size of the VPC, how many people or how many departments, who needs what, who needs this or who needs that in the departments to communicate. That's something you need to identify first. Used network addresses, you cannot give the same ones that someone has already used in the building. So if it's, let's say, a large organization, to keep things simple, I'm going to be a bit extra. For a large organization that has thousands and thousands of people working for it, you have to be careful that you don't use the same network address. So yeah, so again, this one here, the size of the VPC is how many hosts do we need. So 4 departments as we used here. The network is, are there any networks that we cannot use, i.e. some are already in use. If you use the same names, it will confuse you, maybe sending it to the wrong department. So if IT and HR have the same IP addresses, who is it going to? They're both the same, right? Number 3 is predict the future, which is how big this can grow. Maybe different regions, I said it's expanding. So in this scenario or example that we used in the beginning, I said this company is rapidly expanding. So let's say in a year's time it goes from 500 to 1000. Do we need class A? So this is something you need to analyze. Resilience, how many AZs or how many more networks or how many places will you place your networks, or this is a bit more complicated because I haven't covered this here. It's usually we have AZs in Amazon AWS, which is availability zone. So if one fails, it will have a failover system set up which will route the traffic to the second one. So if the first one is on fire or there's an earthquake and the building collapses, it goes to the second place. Okay, this is something you have to consider as well. And common ranges, so you should avoid common ranges like the first 2 of the host. Okay, and that's it really. Thank you very much for watching and listening. I hope this has helped. I will be very happy if you can leave some feedback, like the video and subscribe. Thank you.